Even if we were to convert to full renewable energy tomorrow morning, then we'd still be headed for global climate catastrophe. The CO2, which we've already released into the atmosphere, is going to stay there for hundreds of years, committing ourselves to yet further increases in global temperature. But if the problem is too much CO2 in the atmosphere, why can't we just get rid of it? 75 meters tall and weighing in at up to 30 tons, the red tingle, or Eucalyptus jacksoni, are some of the most massive trees in Australia. Themselves a victim of long-term climate change, today their range is restricted to the Walpole National Park. These trees, just like all other plants, use the process of photosynthesis to take in water and carbon dioxide to convert into sugars using the power of the sun. These carbon-rich molecules are what allow trees to grow. Starting out as tiny seeds, it can take 200 years for the tingle trees to reach these incredible heights, all the time taking in carbon dioxide from the atmosphere. Massive trees such as these ones can store almost 15 tons of carbon, which is great, right up until the tree dies. At this point, decomposers like bacteria, fungi and termites eat the sugars in the trees, turning the carbon back into carbon dioxide. In the long term, trees are carbon neutral. Planting more and more trees is a good, if temporary, solution. But in order to capture carbon more permanently, we need to turn to another giant of the southwest. This is Albany's historic whaling station. Over 1,000 humpbacks and nearly 15,000 sperm whales were caught here between 1952 and 1978. Today, however, it can give us some clues as how we might be able to reverse climate change. Obviously, whales don't photosynthesize, but they can still capture atmospheric carbon in other ways. Humpbacks use their baleen filters to catch krill, small crustaceans which in turn eat phytoplankton. These microscopic organisms photosynthesize to turn carbon dioxide into sugars, just like the trees back on land. Therefore, even though the whales themselves don't capture CO2, they still end up storing a lot of it inside their bodies. Great whales such as these can sequester over 33 tons of carbon dioxide over their 60-year lifespan. When they do eventually die, their bodies sink to the bottom of the ocean, where the carbon remains trapped for millennia. When averaged over their lifespan, this converts to about half a ton of carbon dioxide per year. That's roughly equivalent to manufacturing 340,000 plastic straws, running a fridge for a year, or driving from Perth to Sydney to Cairns. There are also some other ways in which whales can help fix the climate, and another key species which we used to hunt in these waters. Sperm whales definitely don't eat phytoplankton. In fact, they are the largest toothed carnivore on Earth. But they can still play an important role in capturing carbon dioxide. 2 kilometers beneath the surface, in a world of almost perpetual night, they hunt for giant squid, returning with full stomachs and skin covered in sucker scars. By consuming deep-sea creatures and then defecating back on the surface, whales act like a giant nutrient pump. This natural fertilizer promotes the growth of surface-dwelling phytoplankton, of which a small fraction will sink directly to the bottom of the sea. Through this process, each sperm whale contributes to the removal of about 16 tons of carbon dioxide from the atmosphere each year. So, how many whales does it take to solve climate change? While not all whales are going to be as good at storing CO2 or redistributing nutrients as humpbacks and sperm whales, we can assume that your typical whale can remove about 8.5 tons of CO2 each year. In 2019, Team Trees raised enough money to plant over 20 million saplings, estimated to remove almost 1.6 million tons of carbon dioxide over the next few decades. Team Whales could have gotten even further. Not only do whales store CO2 for longer than trees, but they can also capture more of it. 20 million whales could absorb just over 1 billion tons of carbon over their lifespan. Of course, planting trees is a little bit easier than breeding whales. So a more reasonable challenge would be bringing whale stock back up to what it was before the event of commercial whaling. Doing so would remove 30 million tons of carbon dioxide over their lifespan. On a yearly basis, that's enough to counteract the emissions from all of these countries combined. But as we said at the start, stopping CO2 emissions, or counterbalancing them exactly, doesn't stop climate change. It just prevents more CO2 from accumulating in the atmosphere. In order to fix the climate, we need to counterbalance the 375 billion tons of carbon dioxide which humans have released since the Industrial Revolution. To do that using one generation of whales, we would need 735 million of them. That's enough to stretch around the Earth, past the Moon, and a third of the way to Mars. At a certain point, we might start to realize that solving climate change using whales alone is a little bit impractical. But that's the point. Climate change is a really big, really complex issue with no single solution. But by combining local politics and global engineering, human ingenuity with the natural environment, we can start to create a better world. This has been James Dingley from the Atomic Frontier. Keep looking up.